Okay, welcome back to my class. In this video, we want to talk about a difference equation. Now, let us consider this equation. Let's consider equation that yn is equal to a function of n, okay? Where n must be greater than or equal to 0. N must be non-negative, okay? This is called a difference equation. An example to this is, for example, if you remember when you were in secondary school, you talked about sequence and series. When they were teaching you sequence, they can tell you that a sequence Sn is equal to n squared plus 1 all over maybe n, something like this. And then they will not tell you to find the first term, the second term, and the rest of them. Okay? Now, that is a difference equation. Okay? Just see that as a difference equation. The only thing now is that the first term of this one, the n starts from 0. Okay? Well, they could even tell you to find, okay, they can tell you to find when n is 15. They can even tell you to find when n is 0, depending. You understand? But in this case, n cannot be 0 because of that denominator. If n is 0 there, it's going to be undefined. Okay? So you should know that uh, a sequence looks like a difference equation, or let me say that is a difference equation. Just with that idea of sequence you have in your secondary school, just know that that is a difference equation. So an example to that could be something like this, or we say that yn is equal to maybe n raised to power 3 minus 4. Okay, so if you are asked to find the first 5 terms of this sequence, okay, or of this difference equation, we will now know that n will start from 0 and then the rest of them. So the first term here is y0, and y0 means putting 0 here. 0 raised to power 3 is 0, and then I'm having the minus 4 is remaining. So the next sequence here, let me put it in a set, the set of few sequences here. So few sequences here. So the next one is when n is now 1. If n is 1, you have that y1 will now be 1 raised to power this minus this will give you, I think, 3. Minus 3 here. Minus 3. Then y2 will give you 8 minus this, which will give you 4. And so on and so forth. Okay? So that is an example of a difference equation. So to define a difference equation, we say that a difference equation is an equation that okay, they say um, that a difference equation is the equation that follows the pattern this. Now, since we are talking about a difference equation is different from differential equation. Okay, a difference equation, we are interested in the differences. But differential equation, when we are interested in the derivative. So though they have let me say similarities, with your knowledge of differential equation, I think you can do well in a difference equation. Okay, so let's go back to the definition. They say that a difference is defined as follows. A difference is defined as follows. Change in yn, this one is difference. Change in yn is equal to yn plus 1 minus yn plus 1 minus y. Okay? Now, if you have this change in change in y could be anything at all. It could be yn plus 1 minus yn. This is the difference. The difference of this and this, okay, is the change in this, which is equal to yn plus 1 minus y. So when you have something like this, you can just, and this, if this take care of this, you now have that yn is equal to y. Okay, so just something like this is what we call a difference equation. So an equation involving a difference is called a difference equation. Very simple. So any equation that contains a difference is what we know as what? A difference equation. Okay, so an example to that is that we can have that the change in change in yn is equal to maybe 9 plus n squared, or even this we can even have it to be even this one we have here. Change in this is equal to minus 4, something like this. So, and you know that this one could be written as yn plus 1 minus yn is equal to n3 minus 4. So which will now have that yn could be equal to what? Yn plus 1, sorry, is equal to this one moving to this side, have yn plus n raised to power 3 minus 4. So this is what is known as what? A difference equation. So now the next thing we need to know is what? About which one is the dependent variable and which one is the independent variable. Okay, now in a difference equation, the independent variable is the one that is written as sub like this. That is the independent variable. They depend on, why depend on them? They are independent of nothing. So in fact, you even know, their value self, that they start from 0 till infinity. So they don't depend on anything. But why always depend on them? For me to get the first term, you will see that I will need the y to be 0 to have my y0 being equal to substituting here to get minus 4. So without n, we cannot get y. Without n, we cannot get y. So n is what? Independent variable. They don't depend on anybody. And then we can call them the argument. Okay, the independent variable in this case is equally called the argument. So the same thing here. We cannot find s without finding n. You need to know n before you will know s in this case. So the n here is what? The independent variable, which is the argument. Why the what? The s is what? The dependent variable. So that is how to know the dependent and independent variable of a difference equation. So the next thing we need to talk about is the classification. Okay, yes, a differential equation can be classified as first order, linear, homogeneous, or non-homogeneous. Okay, it could be linear or non-linear. It could be what is it called? Homogeneous and non-homogeneous. So now let's talk about the order of differential equation. Difference equation. Now, if you remember that the order of a differential equation is the number of the highest derivative. You understand? The number of the highest derivative, that is for differential equation. Now, but in difference equation, remember we are still talking about the difference between them. So now, to get the order of a differential equation, the order, for us to get the order is simply the difference between the highest term. Okay, do I call it the term? Okay, is the difference between the highest argument. Thank you very much. The difference between the highest argument, okay, or the difference between the highest independent variable to the lowest independent variable. Okay, so please note that the order of a difference equation is gotten from the difference between what? The highest independent variable minus the lowest independent variable, or the highest argument minus the lowest argument. Now, in this case, to get the order of this differential equation, we'll say that the highest order here, the highest argument here is n plus 1. So we'll say that n plus 1 minus the lowest here is n. The lowest here is n. So n minus n is gone. I've gotten 1 here. So which means that this particular one, the order of this particular difference equation is 1. As simple as that. Okay? So the order is simply 1. So the order is gotten by highest what? Argument minus the lowest argument. Okay? Highest argument minus the lowest argument. So that is how to get the order of a difference equation. So the next thing is that let's talk about the linear. A differential equation is linear if all appearance of y are linear. Okay, once you have that all the dependent variable, okay, all the dependent variable are linear, then you now talk about that it is a linear differential equation. If not, it is not a linear differential equation. For example, here, the highest power of this y are just 1. So this is an example of a linear dependent variable. Okay, so the same way you know about linear in your secondary school. And linear means that the highest power must be 1. So if the highest power is 1, the highest power of y, it may not necessarily be y. Just know that the highest power of that dependent variable, if it is 1, then it is linear. But if it is not 1, then it is not what? Linear. So the next thing we'll talk about is what? The homogeneous and non-homogeneous differential equation. Now, A homogeneous differential equation is a differential equation that they say that a differential equation is said to be homogeneous if each term contains the dependent variable. Otherwise, it is not a homogeneous differential equation. Now, for example, now if you see y attached to everything, in fact, if you see the dependent variable attached to everything, you understand, then you call it a homogeneous difference equation. Please, I don't know if I'm making mistake of calling it differential equation. Please, if I'm making that mistake, please help me correct it, because sometimes pronunciation will you will call differential equation instead of difference equation, because we are used to differential equation. So please, I'm talking about difference equation. Okay. So I told you initially, for you to get the what, the linear, whether a difference equation is linear or not, is by the power of what, the power of y. I think that is the same thing self with a differential equation. Yes, I think that is the same thing with differential equation. Okay, so but we are talking about difference equation. So now, how do we know a homogeneous difference equation? A difference equation is said to be homogeneous if the dependent variable is found everywhere. For example, look at this. If you look at this now, you see that this is the dependent variable y here, y here. We don't have y here and we don't have y here. So we call this a non-homogeneous difference equation. But look at this one, for example. You see this one? Everywhere we are seeing y, and y is my dependent variable. So we call this one a homogeneous difference equation. So know the difference. So it is homogeneous when the dependent variable is found everywhere, it's attached everywhere. So note that. So if it is not attached everywhere, then we'll not call it what? A difference, a non-homogeneous difference equation. Okay. So now the next thing we'll talk about here is that, take note that difference equation are also referred to as a recurrence relation or recursion formulas. You can call them recurrence relation or recursion formulas. So note that. Okay. So the next thing we're going to talk about is now the solution to a difference equation. Solution to a difference equation. Now, for the solution for a difference equation, solution of a difference equation are normally labeled as particular or general, okay, depending on whether there are any associated initial condition. Okay, initial condition solution. Okay, initial condition solutions are verified by direct substitution. Now, you should take note that it's the same thing. In fact, like I told you before, once you have the knowledge of differential equation, in fact, you have gotten halfway to the knowledge of difference equation. And if you can remember that the solution of a differential equation is gotten by a general one or a particular one, depending on the initial condition given to you. Okay, so the same thing here. We have the general one or the particular one. And then they say that what? That the solution are verified by direct substitution. The solutions are verified by direct substitution. The same thing with differential equation. When a differential equation, let me give you an example. Maybe you should verify that y is equal to a exponential x is a solution to y prime prime minus plus y prime plus maybe y equal to 0, something like this. What do? You just need to find y prime prime, you find y, then do your direct substitution. If the left hand side is equal to the right hand side, then we conclude that this is a solution to this differential equation. If not, we say that it is not a solution. So the same thing is applicable in difference equation. So we verify them by what? By direct substitution. We do our direct substitution. For example, if I say that verify if, for example, in this one, verify if yn, which is equal to maybe n squared, is a solution to this difference equation. What I need to get is simply, I need to get my n plus 1. So anywhere I see n, I'll put n plus 1. Then I already have my n. I will substitute the left hand side and the right hand side and see if they are equal to each other. If they are equal to each other, I will then conclude that this is a solution to this. If not, I'll tell you that this is not a solution to this. So we get the solution by what? We verify the solution, by direct substitution. Okay? So they say we should note that the theorem of solution in difference equation is virtually identical with that of the differential equation. I have told you that before. Once you know how to solve differential equation, you have a knowledge of differential equation, you have at least gone halfway on this course. Okay, so but don't worry, even if you don't have the knowledge, in fact, I have a full video, a full playlist on differential equation. You can check the link on the description or go to my playlist side on this channel. You will see differential equation, then you tackle it. It's very simple. Okay, so just to go through the videos is very simple. But even if you don't have the knowledge, don't worry, I will be teaching this course as if you don't even know anything about it at all. So even if you don't know anything about differential equation, you are welcome. You are going to learn it here. Okay. So the next thing is now they now told us that okay, they say that the technique of guessing solution are likewise reminiscent, okay, are likewise reminiscent of the method employed for differential equation. We use a guessing solution here as well, the same way we use guessing solution to in differential equation. So okay, they say that we will also use the method of determined coefficients to get a particular solution for a non-homogeneous difference equation. Please, you should take note that all these things I'm saying are just an introduction to what we are going to do. And then by the time I start solving questions, you will now be very happy. You will understand everything I'm talking about. So now I'm still telling stories. So let us look at some examples so that we understand what we are saying perfectly. Okay? So let's see some examples. All right. So the first example here here say that consider the following difference equation and determine the independent variable. Okay, they say consider the following. Consider the following. Let me use D dot E as difference equation in this case. So determine the following difference equation and determine the following. And determine the following. 1, the dependent variable. 2, the independent variable. Like I told you before, that the independent variable can also be called the argument. 3, the order. 4, are they linear? Are they linear? 5, are they homogeneous? Okay. Now, these are the 5 things we'll be considering for each and every equation difference equation I'm going to be writing. So, number one, we have that yn plus 3 is equal to 4yn. Now, obviously, the first thing they say we should get is the dependent variable. I told you that y always depend on n. So y is my what? Dependent variable in this case. Now, the independent variable here is always the n, the one written below is always your independent variable or your argument. Now, the next thing is to get the order. I told you that the order is gotten from the highest independent variable minus the lowest independent variable. So in this case, I'll have that what? N plus 3 minus n. So you see that any taking care of n, you have that what? The order here is 3. So we have that the order is equal to 3. Okay? So the order of this difference equation is what? 3. So the next one is that are they linear? I told you that how do you know that if they are linear? If the highest power of y, which is the dependent variable, is 1, then it is linear. So in this case, this is a linear third order difference equation. Okay. Now the next one is, are they homogeneous? Yes, of course, they are homogeneous because we saw y everywhere. We saw y everywhere. So you now say that, you now conclude that what? That this equation is what? Is third order homogeneous linear difference equation. I hope you got that. So it is a third order, it is linear, and is equally a homogeneous difference equation. That is for number one. So for number two, number two said t subscript I plus 3 is equal to 4 plus t I minus 3 minus 5 t I minus 5. Okay, now look at this. First of all, they say we should get the dependent variable. I thought that the dependent variable is always the big one. So in this case, t is the dependent variable. In this case, okay? So the independent variable is always the subscript. So I is my independent variable. So the next thing here is to get the order. The order is gotten from the highest. This is the highest. I plus 3 is the highest, minus the lowest here is I minus 5 is the lowest. So I minus 5 is the lowest. So put it in bracket. I minus 5 is smaller than I minus 3. So I minus 5 is the lowest. So I'm going to have I plus 3 minus I plus 5. So you now see that I taking care of I, 3 plus this is what? 8. So the order here, the order is what? 8. Okay? Now, the next one is it linear? Yes, of course it's linear. Why? Because the highest power of the dependent variable is 1. So it is linear. Is it homogeneous? No, it is not homogeneous. Why? Because 4 here does not have t attached to it. So it is what? A non-homogeneous. So in this case, I'll say that this equation is what? An 8th order non-homogeneous linear difference equation. Write it down. 8th order non-homogeneous linear difference equation. Okay? So we'll go to question number 3. So for question number 3, so these things are very simple. Question number 3 said, so question number 3 said zk minus zk plus 1 is equal to what? 10. Okay, that is not minus. Okay, they say zk like this. Okay. Now, first of all, they say we should determine what? The dependent variable. The dependent variable is always the big one, depending on the small one. So the dependent variable is what? Is z, okay, depending on k. So the independent variable here is k. Now the order here is the bigger one, k plus 1 minus k. So this minus this, I'm having that the order here is 1. So is it linear? Yes, it's linear because the highest power of z here is 1. Is it homogeneous? No, because 10 does not have the z. So it is what? So you conclude that what? This is what? First order, because the order is 1. First order non-homogeneous linear difference equation is this one. Okay? So we go to the next one. Question number 4. We're going to solve so many questions so that you understand it very well. Question number 4 said fn plus 2 is equal to fn plus 1 plus fn okay, where f0 is equal to 1 and f1 is equal to 1 as well. Okay, so let's look at this. We are not interested in this because we are not solving it. So we just want to know what is what. We just want to answer all these questions. So first of all, what is the dependent variable, the big one? So f is depending on n. So f is the dependent variable. N here is the independent variable or the argument. So to get the order is the highest, which is n plus 2, minus the lowest here is n. So the order here is 2. So n minus n is gone. So the order here is 2. So the next one, is it linear? Yes, it is linear because the highest power of f, the dependent variable, is 1. Is it homogeneous? Yes, because f is attached everywhere. So we call this second order homogeneous linear difference equation. So that is that for question number 4. We go to question number 5. So question number 5 said that yr is equal to 9. 9 cos yr minus 4. Okay, let's go again. You can tell us the answer before. You can pause the video and write the answer at the comment section. Then check if it is the same with what I'm going to say now. Okay, so first of all, the dependent variable here is the big one, y, depending on r. Y is the dependent variable, r is the independent variable. So is it linear? Yes, because the highest power of y is 1, is linear. So now, is it homogeneous? Yes, it's homogeneous because y is attached everywhere. Okay, is it homogeneous? Yes, it's homogeneous. Yes, because y is attached everywhere, so it's homogeneous. So is it so what do we call it? The order. Okay, let's get the order. The order said the highest, which is r is bigger than this, highest minus the lowest. So if they are two like this, always put them in brackets. So I have r minus r plus 4. So the order here is 4. So we say that this is what? This is fourth order homogeneous linear difference equation is this one. So write it that way. Fourth order homogeneous linear difference equation. Okay. So number 6. For number 6, and which is the last one I'm going to be solving for this type of question. So we move to the next type of question. We have 2 raised to power n plus x subscript n is equal to x n plus 8. Okay. The first question, what is the dependent variable? The big one is always dependent on the small one. So x is what? The dependent variable. Yn is what? The independent variable. And the order is always the big one minus the small one, which is 8. Okay, is it linear? Yes, it's linear because the highest power of the dependent variable is 1. Is it homogeneous? No, because I cannot find the dependent variable on 2 raised to power n here. So it is not what? Linear. So we call this 8th order, sorry, it is not homogeneous. So we call it 8th order non-homogeneous linear difference equation. Okay, so let's clean this. I'll move to another type of question. So now, the next type of question I'm going to be solving here says that they say by recursive computation, comma, generate the first 11 Fibonacci number. Okay, Fibonacci number from f n plus 2 is equal to f, small letter f n plus 1 plus f n. Okay, so now this is very, very simple. We're asked to get the first 11 terms. It's very simple. Forget any other language. Forget any other language. They are just talking about. All those stupid language. We need the first 11 terms. So the first term is when n is 0. Don't forget that n is always is what? 0, 1, 2, 3, like that. So the first term is when n is 0. So the first term is when n is 0. You are going to have that, what do we have? Okay, sorry. There is a condition. The condition we have that f of 0 is 1 and f of 1 is 1. Okay, so these are the conditions we have. So now, to get our first term when n is equal to 0, we are going to have if I put 0 here, I'm going to have that f2 is equal to what? We have already gotten our f0. So our f0 is equal to 1. Our f1 is equal to 1 again. So we need f2, f3, and so on. Okay, so this is our first, second. So now when n is 0, it will help us to get our f2. So our f2, we will have what? f1 here, because 0 plus 1 is 1, plus what? f0. So I'm going to have that my f2 will now be 1 plus 1, which is equal to what? 2. I've gotten that my f2 is 2. So should I be writing it here? f0 is 1, f1 is 1, f2 is 2. So let's move to f3. So for us to get our f3 is when our n is 1. If n is 1, I'm going to have this plus this to give you 3 is equal to what? f2 plus what? f1. So I'm going to have, this is 2 plus 1, which will give us what? 3, right? So our f3 is equal to 3. So we move to f4 and the rest of them. So what do you think f4 is going to be? So don't just conclude that it's going to be 1, 2, 3, 4 like that. No, don't conclude. So just find it by yourself. When n is now 2, it will help us to get our f4. So f4, because 2 plus 2 is 4. f4 is equal to 2 plus 1 is 3 plus f2. Okay, so I'm going to have f3 I've gotten as 3 before plus 1. So, sorry, plus f2, and f2 is 2. You see that here I'm getting 5. So my f4 is equal to what? 5. So continue that way to give me f5, f6 up to f11. So tell me what it is in the comment section. So the more you solve it, is the more it becomes part of you. So just calm down, pause the video, do up to f11, and then write them out at the comment section. Okay, just be writing for me. f5 is this, f6 equals this until f11. I'll be expecting that on the comment section. Okay, so let's move to the next question. So the next question here said we should verify that yn, which is equal to what? C in bracket of 4 raised power n. 1 minute. Okay, C in bracket of, so we have that this, what do we have? Where, okay, they say that where C is any constant. Okay, where C is any constant, then we should, okay, solves the difference equation. The difference equation yn plus 1 is equal to 4yn. Like when I was doing the introduction, I told you that how do we verify a difference equation? We verify by just direct substitution. So by direct substitution, let us get what will be our yn plus 1. Yn plus 1 means anywhere I see n in the right hand side here, I'll put my n plus 1. So here is going to be C in bracket of 4 raised to power what? N plus 1. Okay, that is for this side. Is equal to, I have 4 in bracket of yn, and my yn is just everything here, which is C 4 raised to power n, like this. Okay, now I have this to be C in bracket of 4 raised to power n multiplied by 4 raised to power 1 according to indices. Okay, or let me leave this one to be like this, is equal to, let me bring this inside. So according to indices, this is raised to power 1. So this is 4 times 4, which will give you, take one of the 4, then you add the power. according to what indices said. Don't forget that my C is always here. So I can bring the C outside. This is C in bracket of 4 raised to power n plus 1 is equal to C outside in bracket of 4n plus 1 like this. Okay? So that is that. Or let me even have this side to be. Bring this one in, bring this one outside. So C in bracket of 4 raised to power 1, 4 raised to power 1 multiplied by 4 raised to power n. So, and according to indices, we can add the power. So to have this. So since the left hand side is equal to the right hand side, we now conclude that this is a solution to this. Okay? Or this solves this. As simple as that. Just by direct substitution, you get your answer. So the next question we are going to be solving, thought we will be solving so many questions so that you can understand it very well. So the next question we are going to be solving here said, so consider the difference equation. Consider difference equation an plus 2 plus 5a n plus 1 plus 6an is equal to 0 with the imposed conditions that a naught is equal to 1 and a1 is equal to what? Minus 4. Then I say we should verify that an, okay, verify that an is equal to 2 into minus 3 raised to power n minus into minus 2 raised to power n, okay, solves the equation and satisfies both conditions. Okay, now this one is very simple. First of all, let's talk about satisfying both conditions. If we want to check if it satisfies both conditions, that means that we need to get our a. Let's verify if our a naught will give us 1. So a naught giving us 1 means that n will be equal to what? 0. So let us put it here. A naught will now be equal to what? 2 into minus 3 raised to power 0 minus into minus 2 raised to power 0. And anything raised to power 0 is 1. So I have 2 into 1 minus 1. So which will give you what? 2 minus 1 will give you 1. So, and our a naught is 1. So it has satisfied the first condition. So the second condition is that n1 is 4. So let us put n to be 1 here and see if we are going to get 4. Okay. So I'm going to have that my n becomes 1. If my n is 1, I have that a1 is equal to what? 2 into minus 3 raised to power 1 minus into minus 2 raised to power 1. So I'm having 2 into minus 3, then minus into minus 2, because anything raised to power 1 is still the same thing. So I'm having that this is minus 6. This time this will give you plus 2. Okay, which will give you what? Minus 4. You see? So the both conditions are satisfied. We have done this one. So the next one is to check if this solves this. So what do? We need to get our an plus 1, an plus 2, and get our an plus 1. Then put it inside this equation to know if we are going to get the right hand side 0. So permit me to clean this one that I have already done. So for us to get what will be our let me substitute directly. So to get an plus 1 is anywhere I see n, I'll put n plus 2 means anywhere I see n here, I'll put n plus 2. So I have 2 into minus 3 raised to power n plus 2, okay, minus, or let me just write it out and then we now substitute so that you will not be confused. So for us to get my an plus 2 is equal to anywhere I see n here, I will change it to n plus 2. So this will now be what? 2 into minus 3 raised to power n plus 2 here minus 2 raised to power n plus 2. So this is that. So let me get for a n plus 1. It will now be 2 into minus 3. Anywhere I see n, I will change it to what? N plus 1 minus 2 into what? N plus 1 again. So now I will carry this one and this one, the three of them, and substitute in this equation to see if I'm going to get the right hand side 0. Once I get the right hand side 0, I will now conclude that what? That it satisfies that, so that it can solve it. So let us substitute. So for direct substitution, permit me to draw this like this. For direct substitution, this one gave us 2 into minus 3 raised to power n plus 2 minus into minus 2 raised to power n plus 2. Okay, then I have plus 5 into this one now, 2 into minus 3 raised to power n plus 1 minus into minus 2 raised to power what? N plus 1. Okay, then I'm going to have plus 6 into my an. My an is 2 into minus 3 raised to power n minus into minus 2 raised to power n again. Okay, want to check if we solve all these, are we going to get 0? So let us solve it gradually. So solving it gradually, I'm going to be having okay. Solving it gradually, let me break down all these ones. So I have 2 into breaking this one down, I'm going to have minus 3 raised to power n multiplied by minus 3 raised to power 2. Okay, according to indices, this one can be split into minus 3 raised to power n multiplied by minus 3 raised to power 2, because indices say that if we have multiplication, we should do what? We should add the power. Or if we have addition, we should multiply the base. So having this now, so we have minus this one, separating this one, I'm going to have minus 2 raised to power n, then multiply by minus 2 raised to power 2. Are you getting that now? So plus, for this one is 2 times this is 10. So I'm having 10 into, break this one down to have minus 3 raised to power n multiplied by minus 3 raised to power 1. Okay? Then minus, okay, sorry, close this one. Then 5 times these people will have minus 5 into, again, into, split this one to be what? Minus 2 raised to power n multiplied by minus 2 raised to power 1. Okay? So plus again. So we go again. This time is to give you 12. So I'm having 12 into minus 3 raised to power n, then minus 6 into minus 2 raised to power what? N. Okay, so let us now clear. To clear, this is equal to, so to clear this one will now be minus 3 raised to power 2 is 9. 9 times this is 18. So I'm having 18 into minus 3 raised to power n. Okay, so for this one, I'm going to have that this squared is 4. So I'm going to have minus 4 into minus 2 raised to power n. So I am done with this part. So plus, so this part will give me, in fact, minus 3 raised to power 1 will give you minus 3. Minus 3 times this will give you minus 10. So I have, okay, sorry, minus 30. So I have minus 30 into minus 3 raised to power n. Okay, so for this one, I'm going to have minus 2 times minus 5 will give you plus 10. So I have plus 10 into minus 2 raised to power n. So this one will now be plus 12 into minus 3 raised to power n, then then minus 6 into minus 2 raised to power n. So now, let us now do the addition and subtraction. So I'm going to have, for all the people that has minus 3 raised to power n, let us add everything. This one has it. So I have 18 is the coefficient, minus 30. Okay, 18 minus 30, then plus 12. Okay, so that means, let me write it this way. This is 18 minus 30 plus 12. So all of them has minus 3 raised to power n in common. Plus, let me bring out those that has minus 2 in common. So I have minus 4 here, plus I have 10 here, then I have minus 6, and all of them has minus 2 raised to power n in common. Now, if you look at it, you see that if you add everything here is 0. 0 times anything is 0. Plus, if you add everything here is 0. 0 times anything is 0. So 0 plus 0 is 0. So which is exactly the right hand side. So we'll now conclude that what? that this equation solves this equation, okay, and equally satisfies the condition given. As simple as that. As simple as that. Okay? I hope you understand, and I hope I'm not rushing it. If I'm rushing it, please, you can rewind it, go back, and then watch it again. So it's very easy. It's very, very easy. So the next question I'm going to be solving, they say that verify that P base n is equal to C1 3 raised to power n plus C2 5 raised to power n plus 3 plus 4n, okay, where C1 and C2 are constants, okay, satisfies the difference equation P n plus 2 is equal to 8p n plus 1 minus 15pn plus 32n. Okay? Now, what you do for me is pause the video and then try to solve it by yourself and see if you are following what we are doing. Okay? So then after that, you come back to see if you got the answer correct. If you got the answer to correct, say, I am proud of myself and my teacher. Yes. If you get the answer, just say, I am proud of myself and my teacher. Okay? Say it in the comment section. I will know that, yes, you got the answer. Yes, I'll be there in the comment section to tell you that I'm equally proud of you. So now, it's very easy. The same method. It does not change. So the first thing we do is what? We find what will be our Pn plus 2, and then find what will be our Pn plus 1, substitute all of them and see if the left-hand side will give us exactly what is in the right-hand side. So for left-hand side, left-hand side, we need our Pn plus 2. And our Pn plus 2 is anywhere we see n here, we'll say n plus 2. That is C1 into 3 raised to power n plus 2 plus C2 into 5 raised to power n plus 2. Okay? Then plus 3 plus 4 into n plus 2. Okay? So if you clear this thing very well, you're going to be getting that. Now, separating this one will give you, separating 3 raised to power n plus 2 will give you 3 raised to power n multiplying by 3 raised to power 2, which will give you 3 raised to power n multiplied by 9. Okay? So 9, this thing now is replacing this one. So 9 times that C1, I'm going to have that here will now be 9C1 into 3 raised to power n like this. Okay? Plus, if you do the same thing here, this is 5 raised to power n plus 2, which is the same thing as saying 5 raised to power n multiplied by 5 raised to power 2. And 5 raised to power 2 is 25. So I'm having 5 raised to power n multiplied by what? 25. So 25 times C2, I'm going to have 25 C2 then in bracket of what? 5 raised to power what? N. Okay? Then I'm having plus 3 here, plus 4n plus 8. And then 8 plus 3 will give you 11. So instead of writing this one, I'm going to write 4n plus 11. So 4n plus 11, or 11 plus 4n, anyone. 11 plus 4n. Okay, so this is our Pn of 2. So now let us get our Pn of 1 and then get substitute and see what we are going to get. So for our P from the right hand side, for our Pn plus 1, let's see what this one will give us. In fact, let's see what 8Pn of 1 will give us. Okay, or let's see what Pn of 1 will give us. Later, we now multiply by 8. So Pn of 1 is that anywhere we see n here, we put n plus 1. So I have C1 into 3 raised to power n plus 1 plus C2 into what? 5 raised to power what? N plus 1 plus 3, then plus 4 into n plus 1. Okay? So this will now give us, now the same thing we did here. This one, 3 raised to power n plus 1 is the same thing as saying 3 raised to power n multiplied by 3 raised to power 1. And 3 raised to power 1 is 3. So 3 raised to power n multiplied by 3. So 3 times that C1. So I'm going to have 3C1. Then I'm going to have 3 raised to power n. Okay? Plus, the same thing is applicable here. 5 raised to power n plus 1 is same thing as saying 5 raised to power n multiplied by 5 raised to power 1. So which is something as saying what? 5 raised to power n multiplied by 5. So 5 times C2. I'm going to have 5 C2. Then in bracket of 5 raised to power what? N. Then plus, this one will give you 3 plus 4n plus 4. And 4 plus 3 will give you 7. So instead of this, I'm going to write 7 here and then remove the 4 here. Okay? So this is our, now let's get what 8p n plus 1 will give us. Just multiply everybody by 8. 8 times 3 will give you what? I think 3 times 8. I have 24. So I have, this is 24 C1 in bracket of 3 raised to power n plus 8 times 5 is 40, right? 5 times 8 is 40. So I have 40 C2, 5 raised to power what? N plus 8 times 7, 8 times 7, 8 times 7. So I have 56. So 56 plus, this one is now 32n. Okay, this is what our 8p will give us. So what about our our 15p? Okay, our 15p. Our 15p. Or let me say rather, our minus 15p. So our minus 15p is to use minus 15. I'm talking about minus 15p. I want to get everything. So minus 15p is to use minus 15 to multiply everything here. So I have minus 15 C1, 3 raised to power n, minus 15 again, C2, 3 raised to power n, minus 15 times 3. 15 times 3 is 45. So minus 45. Then minus 15 times 4. 15 times 4 to give you 60 minus 60. Okay. So now, you know that my board is too small. So permit me to... So we are going to add everything. So we're going to add this plus... That is, we're going to add this plus this plus this to see if we're going to get exactly this. So we're adding this, this, and this to see what we're going to get. So we have, that is 3 plus 24 minus 15. So 3 plus 24 minus 15. So I'm having 12. It does not work. Oh. Let me see the question. Verify. So where is the problem coming from? Let's see. Okay. Let me check if I'm correct with my equation. 8p, where is the question? Minus 32n. Okay. It's not a must, they must be the same thing, no. But I'm just saying. Oh, sorry. I was actually adding this and this. Sorry. I'm supposed to add only this and this with this 32n. So I'm adding only these two things, please. That's a mistake. So I have 24 minus 15 to give you 9. I don't say that they must be, it must satisfy it. Oh. In some condition, it will not satisfy. You tell them that it does not satisfy. But I have solved this before, so I know it satisfies. So that is why I'm checking where the error is. So what I'm supposed to add is 8pn with these two. Then I will now add this to it. If not for my board, I'm supposed to write it long this way so that you'll be seeing it. But we can still do it here. So this plus this is giving me 8. So it's giving me 9c1. So write your own very long so that you will see it. 9c1, 3 raised to power n. Okay, for all the c1. So let's go to all the c2. All the c2 is 5 minus 15 to give you what? Is it 5? I'll be 4. Sorry, 40 minus 15. 40 minus 15 to give you 25. So I'm having plus 25c2, then 5 raised power n. Okay, so let's go to the one that has a number. So for the one that has a number, is for 8pn, which is 56 minus, I think there's a problem here, 15p. I think I forgot the n here. Yes, I forgot the n here, sorry. So the one that has number is what? 56 minus 45. 56 minus 45. So I have 11. So this is giving me plus 11. So the one that has n. Now watch what is going to happen here. For the one that has n should be. Look at that. Don't forget I have n here. Sorry, you know that I'm adding everything here. So this one is here. Don't forget this. In fact, if you write it long, if you put this one here, and put this one, you will see that this one is included in what you're adding. So for those that has n, I'm adding 32n plus another 32n, then minus 60n. So 32 plus 32 minus 60 to give you 4. To give you 4n. So this is plus 4n. Now, if you check what we got in the right-hand side, that is my right-hand side, is exactly the same thing we got at the left-hand side. This is my left-hand side. Check it out. It's the same. So since they are the same, you will not tell them that what? That this equation solves this. Okay? Or it satisfies that this satisfies this. As simple as that. So write your own properly to see if it will be clear to you. You know, my board is what is my problem. So I'm trying to squeeze out where I'm going to write it. So that is it for this particular question. So we move to the next question. So the next question said, so they say consider the difference equation y n plus 1 is equal to minus 6yn. Okay. Then I said by guessing that yn is equal to p raised to power n, okay, for p not equal to 0, then I say we should find for p not equal to 0. Where is the question? Okay, find a solution to this equation. Find a solution to this equation. Okay? So to find a solution to this equation is very simple. Now, they have given us by assumption, by guessing, that yn is equal to p raised to power n. So therefore, to get this one, yn plus 1 is equal to what? P raised to power n plus 1. Then substitute, you are done. So if you substitute it in this equation, I have what? Pn plus 1 is equal to what? Minus 6 what? Pn. So that becomes the solution. As easy and simple as that. Okay? So now we can continue. If you want to solve further, you can decide to solve further. If you decide to solve further, you're going to be getting that this is Pn multiplied by P is equal to what? Minus 6 Pn. Okay? Minus 6 Pn if you solve further. So now, we are even supposed to solve further. So if you look at this, you will see that divide, if you want to get your P, let's get our P. P will now be equal to what? Minus 6 Pn divided by what? Pn. So therefore, Pn, taking care of Pn, I'm having the minus 6. So sorry, the solution, I made mistake. So this is what they say is the solution. So we just need to find our P. So the solution, by guessing, so the solution becomes yn is equal to p raised to power n. So yn is equal to what? Minus 6 raised to power what? N. So that is the solution to that difference equation. Okay, sorry about that. So after substitution, you get your p, then come back and substitute. That is the solution to that difference equation. Okay, we go to the next question. Right? Told you we are going to be solving so many questions for you to understand what we are talking about. So I think maybe if we solve two questions, one or two questions, then we conclude. Okay, so the next question here say using the guessing technique, using the guessing technique, using the guessing technique, okay, find the, let me call the general solution. Find the general solution to 3b n plus 2 plus 4b n plus 1 plus bn is equal to 0. Okay, so now solution. So remember our guessing technique said that what, that our bn will be equal to what, b raised to power n. That is just the guessing solution. Okay, just remember it. So but if it is y, you say yn is equal to this. So for us to get this one, then substitute. So we're going to get that our bn plus 2 will now be what, b raised to power n plus 2. Then our bn plus 1 will now be equal to what, b raised to power n plus 1. So if we substitute here, we're going to be having 3b raised to power n plus 2 plus 4b raised to power n plus 1 plus b raised to power n is equal to 0. Okay, so now if you break it down, we're going to be having 3 into, this one is something as saying b raised to power n multiplied by b squared. Okay, then plus 4, this one is going to be what, b raised to power n multiplied by b raised to power 1, then plus b raised to power n is equal to what, 0. So we're going to have that this will give us 3p squared into b raised to power n, like this. Okay, then plus this one will now be 4p in bracket of p raised to power n. Okay, then plus what, p raised to power n is equal to what, 0. Now if you look at it very well, you see that they have p raised to power n in common. So p raised to power n they have in common. I'm going to be having 3p squared plus 4p plus 1, okay, is equal to 0. Now when the product of two things is 0, automatically one of them must be 0. And p raised to power n is not equal to 0. So therefore, 3p squared plus 4p plus 1 is equal to 0. So this is the quadratic equation and we can factorize. If you factorize this, I'm going to have the easiest part of factorization, 3p and p, 1 and 1. You check if it is correct. To check, this time this will give you 3p plus, this time this will give you p. And both of them is giving me 4p. Immediately they gave you 4p that is in the middle. Your answer becomes these two people. The answer becomes that 3p, okay, plus 1 and p plus 1 is equal to 0. So finally we have that what? That 3p plus 1 is equal to 0, or p plus 1 is equal to 0. So p here becomes minus 1 over 3, or p here becomes minus 1. So the solution now becomes, the solution, I hope I can clean this. Let me clean this side. So remember, you go back to the solution. So we said that the solution is what? B raised to bn is equal to this. So bn will now be equal to what? Minus 1 over 3 raised to power what? N. Okay. Plus minus 1 raised to power n. The two of them. You add the two of them, I guess. So, but you have to add the arbitrary constant anyways. You have to add the arbitrary constant. Bn is equal to, let me say, a and then b. So you have to add the arbitrary constant. This is the normal way you solve second order homogeneous differential equation. I told you that once you have the knowledge of differential equation, to solve difference equation will be very easy for you. Okay, so that is the solution to that equation. So we move to where a and b are what? Arbitrary constants. So we move to the next question. So you can verify if it is true. I hope you know you can verify it is true. So just work on this, substitute it here to see if you get 0. You can verify if it is true using our normal method of verification. Yes, you can verify if it is true. We move to the next question. So the next question here says, the next question here said we should solve dn plus 1 is equal to what? 2dn plus 6n by guessing. By guessing a solution of dn to be equal to what? an plus b. Okay? Where a and b are constants. Okay. Solution. The same method, it does not change. So we need our dn plus 1, which is same as what? A into what? N plus 1, then plus b, which will give you what? An plus a plus b. As simple as that. So now let us substitute the left hand side, substitute the right hand side. Substituting the left hand side, I have that the left hand side gave me an plus what? A plus b is equal to the left hand side, which is what? 2 into what? An plus an. The n there is not a subscript, oh please. The n here is not a subscript. If it's a subscript, you write this is not a subscript, oh, it's a normal an plus, where is my an plus b? That is this one. Then plus what? 6n. Okay? So now open the bracket there. You have what? An plus a plus b is equal to what? 2an plus what? 2b plus what? 6 what? 6n. Now what we do is what? By comparison, we are going to compare the left hand side and the right hand side. Now, on the right hand side, who has n? Bring out everybody that has n on the right hand side. And we have what? 2a has n. Who again has n? 6 has n. Or you can just say 2an plus 6n. All of them has n. Will be equal to what? Who has n on the other side is what? An has n. So n will cancel out everywhere to see that 2a plus 6 is equal to a. So collecting items, you're going to see that 2a minus a is equal to this one moving here minus 6. So a becomes what? Minus 6. I've gotten my a. So by comparison again, who does not have n in the right hand side? Who does not have n in the right hand side? That is 2b does not have n in the right hand side. Should be equal to who does not have n in the left hand side? Which is what? A plus b does not have n in the left hand side. So if I collect items, I'm going to have that 2b minus b is equal to what? A. So this minus this is what? B. B is equal to A. And I've gotten A before, so my B becomes what? Minus 6. So the solution becomes, from your guessing, the solution becomes what? dn is equal to what? Minus 6n minus 6. That is the solution to that that difference equation. Okay? So, right? So let's solve one more question. Let me see my time. Okay, let me solve one or two more questions, then I will conclude the lecture. I think we've tried. Right? So the next one said, consider the difference equation. Consider the difference equation yn plus 2 plus 6yn plus 1 plus 9yn is equal to 0 using the guessing technique presented in 11ii 24. Okay, using the guessing technique that y subscript n, all these things is subscript to n plus 2, please. Y subscript n is equal to p raised power n. Okay, so let's use this guessing technique to solve this. So solution, I think this is going to be the last question I'm going to be solving here. Okay, so solution. Now we need our y n plus 2, which is what? P raised power what? N plus 2. We need our y n plus 1, which is what? P raised power n plus 1. Now, let us now substitute here. So this is going to be what? p raised to power n plus 2 plus 6 into p raised to power what? N plus 1 plus 9 into p raised to power n is equal to 0. So let me reduce this. So it's going to be p raised to power n multiplied by p squared plus 6 into p raised to power n multiplied by p, then plus 9 into p raised to power n is equal to 0. So if I write this very well, I'm going to be having p squared into p raised to power n. Let all the p raised to power n be inside a bracket, plus these two will give you 6p into p raised to power n, okay, plus 9 into p raised to power n again is equal to 0. So we can factorize. They have something in common. So since they have something in common, I'm going to be having p raised to power n they have in common. You have p squared plus 6p plus 9, okay, is equal to 0. So when the product of two things is 0, automatically one of them must be 0. And we know that p raised to power n is not equal to 0. So therefore, p squared plus 6p plus 9 will now be equal to 0. So this is factorizable. We can factorize it by using the shortest method of factorization, which you have p here, share this into 3 and 3 and check if it is correct. If you check, you can watch my video on factorization if you don't understand this method, or use any method of quadratic equation you like. Okay, so I have to check it. You cross multiply. That is 3p plus 3p, which gave me exactly 6p that is in the middle. So since I have the 6p that is in the middle, my answer becomes this 2, which is what? P plus 3 into what? P plus 3 is equal to 0. So when the product of two things is 0, one of them must be 0. So I have that p plus 3 is 0, or p plus 3 again is 0. So we have that what? Our p is equal to minus 3 twice. Minus 3 twice. So if you now come here, look at how your answer will look like if you have the same result. So we have that our yn will now be what? P raised to power n. Okay, so our yn will now be what? We have minus 3. So minus 3 raised to power n, okay, plus is repeated. Minus 3 raised to power n. I think you should attach p to it. I think that is how it is done. Let me check again. Okay, I forgot our arbitrary constant. Sorry. I forgot our arbitrary constant. So our arbitrary constant, we have that yn should be equal to a into what? A into minus 3 raised to power n plus bp. Then I have the same minus 3 raised to power n. I added this p because they have the same solution. Okay, I added, is it p or n? Sorry, the subscript is what we're adding, not p, sorry. Subscript bn, sorry, the subscript. So we added this because the independent variable is what you're supposed to add, sorry. Okay, so I'm going to have, this p is a constant, so we don't need to add it here. We're adding the independent variable. So this could be written as what? A plus bn, then all raised to power what? All in bracket of minus 3 raised to power n. So that is the solution to that. So thank you very much for watching. Please don't forget to like our video, share to your friends, subscribe. May the peace of the Lord be with you. Bye-bye.